The next set of problems we're going to consider are the ones involving graphs. Our graphing problems include 1, 4, 5, 10, and I believe 19. We'll begin with this group with problem 1. You'll see these problems in physics, you'll see these problems in chemistry, you'll see these problems many places. Joe rides his bike at a steady pace. What do we say about slope? Slope represents rate of change. So a steady pace is a constant rate of change. If his speed does not change, the slope is 0. If your speed remains constant over time, the slope is 0, because if the speed remains the same, change in y over change in x is 0 change in y over some amount of time. So first we are looking for a graph with a constant speed. So now we're down to C and D. He rides his bike at a steady pace up a hill. Steady pace. Up a hill. No, you don't look at the shape of the hill. It's not a position graph, it's a speed graph. Constant rate, steady pace. He then rides down the hill and his speed increases. Well, this looks like down the hill, but no. He's slowing down here. The speed is going down. Constant rate, then up the hill and his speed increases. What you want to do when you read the text is match the graph to the shape of what he's doing, and that would just be wrong. This is a question about slope, constant speed, slope is 0. Going down the hill, his speed increases over time. The answer is D. Next one is number 4. Thomas collected the data about weights of cars and miles per gallon. This is a perfect example of negative correlation. As the weight gets bigger, the mileage goes down. As x, the independent variable, as x increases, f of x, the dependent variable, the variable that depends on the value of x, decreases. The bigger x gets, the smaller y gets. This is a perfect example of negative correlation. No correlation, not true. Positive correlation, not true. Positive correlation would look like this. Negative correlation, absolutely true. Negative correlation followed by positive correlation, I'm not seeing it. The answer is C. The next problem we're looking at is problem 5. Okay, the big problem with number 5 is not. I have a lot of trouble with the knots. They give us ordered pairs. One of these does not work. They give us a function $12.89, $16.99, $20 $1.09, $32 $1.39. Is this a correct representation? Yes, it is. So this cannot be the answer. This is looking like 12. That could be 89. 16.99. That looks a little too high to me. 20 $1.09. 32, and that looks a little too high to me. I'm not liking those at all. The domain 12, 16, 20, 32, I can check my calculator. .59 plus 0.025x. Now I go to my table and I go I'm going to have my table start at 0. At 12. $89. At 16.99, at 20, 109, and at 32, 139. So this one is correct. $12.89 and $12.99? No possible way. Okay, so now I'm down to 1 or 2. $12.89, 16. This is over $1, and this is over $1.40. I don't like this one either. Which one is not a correct presentation? This one is a correct presentation. This one is not correct. This one is correct. This one is not correct. I want which of the following is not a correct presentation. I want the ones that are not correct. That would be 1 and 4. My answer here is D. What was tricky about this problem? It was tricky because we had a double negative. We had a not, and some were correct and some were not correct. So that's what made that tricky. Showing our work made all the difference on problem 5.